All right, how's it going? Um, all right, so we're going to pick up where we left off from last class. And this is creating a variable and seeing how it works. Okay. So now we're going to actually create variables and we're going to show a result in the Unity console. At this point, don't worry about all the details. You're going to be copying code and just assuming that it's going to work. But we will get into the details in the next couple chapters. All right. Don't stress over the details at this point. All right, so let's do this. All right, so we're doing something different here. So I'm going to get rid of the total entirely, right? And I'm just going to do that for now, right? Okay. We have a public int, not my number. We're going to leave them output text, right? We'll talk about that in a little bit. So we're going to say debug.log to 9, right? Debug.log 11 plus my number. So first we're going to make it exactly like it is in the book, and then I'll show you what else we have to put in there. All right. So we're going to save that. We did. We're going to come back to Unity. We'll run that. Make sure your console is open. And let's see. Oh, what? All right. 1 second. All right, so there we go. As you see here, we have 11 and 11, right? And that would be, in fact, that's not correct. So 1 second. Okay, so this comes to the gotcha that comes later in the down here, watching for possible gotcha when using public variables. All right, because we have used this script before, right? If you look at the answers, we've got 11 and 11, right? But if you look in the inspector for the script over here, we see my number is 0. So in fact, 11 plus 0 is 11, right? We were expecting it to be 20 because my number is 9 right here. But if you look in the book a little further ahead where it says possible gotcha, right? All public variable values are overridden by the Unity Inspector tab. So if there's something in the inspector, in this case 0, it is going to override this 9 right here. So what you want to do, there's a couple of answers to this, and we'll talk more about it in the future. But before you start it, you want to hit 9 right there, and then you want to run it. And now you see 11 and 20. There's a certain order that these values get computed in, and we'll learn more about that as we go along. All right, but for now, just know that all public variables values are overridden by the Unity Inspector tab. All right, so back to where we were. All right. All right, know that when you create a variable, there's two parts to it. There's a declaration and there's an assignment, right? The first part is called the declaration, right? And in fact, you can do them in 2 different steps. So in this case, we could have cut that out entirely, right? And then in here, said my number equals 9, right? Like that. So in this case, we have split the declaration from the assignment or initialization, right? Initialization is just the first time you've assigned something, right? The initial time, and you always need to do that, right? You never want to use a variable until you've put something in it, because that can cause problems. But at any rate, the initialization is just the first assignment, right? So it's when you say, hey, we have this spot in memory, let's put something in it. All right. And that's what we saw there. All right. All right, changing variables. All right, changing variables. Since my number is a variable, that means the value can change, right? So we want to try this to stop Unity if it's running, right? It's not. We're going to change the 9 to 19 and see what happens, right? So we're going to go in here, where here's 9 and turn there to 19, enter, press play, and then watch what happens. 11 and 30. That shouldn't be surprising, right? The public keyword at the very beginning of the line declares that my number variable. The public is called an access modifier, and we'll learn more about that later because there are private ones as well, right? From now, we're going to make most things public, and what public means is that you can access it in the inspector. As I told you before, when they are public, the inspector values would override the values that you put in your script, but not totally, right? There's an order to that, and we'll get to that in a little bit. All right. Okay, so when we write a script, the lines of code typically get executed or ran one line at a time from top to bottom, right? But sometimes we don't want that order to be the way it happens, right? We want the code to take branches and do different things determined by what's happening in our game, right? We can do this when we need a piece of code that's reused a lot. We can create what's called a method or a function. And we're about to learn that right now, right? Now you will see that the terms method and function are used interchangeably in this book. And that's fine with me. If you end up going to a 4-year university, you will find out that method and function to the professors mean something different, and they will get really upset if you use them interchangeably. I do not care about that because they are functionally the same thing. So in this book, in this class, we're going to use them interchangeably. All right. As he says here, he uses method throughout the book because that is consistent with object-oriented programming, which we'll get into in a little bit. All right. All right, so we're going to edit the variable script again as in the following screenshot. There are a few lines of code that look strange, right? We're not going to get into the details of what they do. Just kind of follow along, and we'll get there. All right, so I'm going to edit this file to look like that, right? So we're going to leave our output text. I'm going to say public int number 1 equals 2, public int number 2 equals 9. Right. Start function is empty, the update. All right, this is a key point here, right? Note that we have a method. This is void add two numbers. This is called a method, right? Note up here in the update function, there's a call to this add two numbers. You never want to call a function until you define it. So we're going to pop, before we even finish the update function, we're going to pop down here and say void add two numbers. And we'll say debug.log number 1 plus type number 2. All right, and now that we've defined that function, we can come up here and say if input dot get key up key code return add two numbers. See, because I defined it before I tried to use it, now code completion does the work for me, and I don't even have to finish typing all that, right? So I just hit tab and it finishes for me. All right, so now we've saved it. We're going to run this thing. All right, see what happens. Now, what you'll have to know here is that click inside your game window. Nothing happens. It appears there's nothing going on. See, your console is empty. Click inside your game window to make sure that's the active window. If you look at your code, it says if input key get key up return. It is waiting for you to hit return before it does anything. So put the focus inside your game window and hit return, and you'll see 11 down here. All right. I have to remember that when I'm grading it too. I'm not sure why the author decided to throw that in there, just kind of willy-nilly, but he did. Anyway, so that's that part. All right, method names are substitutes too. All right, earlier we learned that variables are just really, when the compiler reads them, they really just substitute the value in the code where the variable is placed, right? It substitutes the value of what the variable contains, right? A method is no different. When you place the name of a method in code, it actually substitutes the whole body of that method in your code, right? So your void add two numbers, that add two numbers is the name of the method, right? Like a variable, add two numbers is nothing more than a name placeholder in memory, but this time it stores some lines of code instead, right? The method name add two numbers is called when this is called, right? This means that the code between the curly brackets is executed. Of course, add two numbers method has only one line of code to execute, but a method can have many lines of code, thousands, millions of lines of code, actually. All right. And then they talk about running this thing, which I just did. All right. And line 16 waits for you to hit the enter key. Let's see. All right, so we just learned how a method works to allow a specific block of code to be called in order to perform a task. And that's all we needed to do right now. All right. Introducing the class. All right, so what is a class? You've seen them already. If you look at it here, we say right here, public class, right? But as you know, Unity likes to call these scripts. But as the author's making a point of telling you that we're trying to teach you some basic programming skills, and all scripts are actually really a class when it comes to C#. And classes are, you'll be familiar if you've taken Java or C++, any object-oriented language, they use the term class. And a script is like a blueprint or a written description. It's just a single file in a folder on our hard drive, right? When we tell Unity to attach it to a game object, we aren't creating another copy of the file, right? What we're doing is telling the game object, we're telling Unity what the behaviors described in our script to be a component of the game object. When we click play, Unity loads the game object in the computer's memory. Since the script is attached to a game object, Unity also has to make a place in the computer's memory to store a component as part of the game object. The component has a capability specified in the script. Not every class has to be a Unity component. In object-oriented programming, you use classes to organize the project. So he kind of goes down this rabbit hole too early, in my opinion. But just know that right now, the script and the class are synonymous for our purposes right now. Right? We'll learn more about object-oriented programming later on, but the author wanted to kind of throw that out there since you're seeing these scripts and classes all the time, right? Inheritance. This is part of object-oriented programming as well. Classes can inherit from other classes, and he's just telling you about this because the basic class in Unity inherits from what's called mono behavior. That is the basic class in Unity. And that the colon is what denotes the inheritance, right? So variable script inherits from mono behavior. That's how you read it, right? Or is derived from mono behavior. All right, and we'll talk more about that later as well. All right, the start, update, and awake methods in the execution order. All right, this is very important. The start, update, and awake methods are called automatically. In other words, you don't have to type in their name to have them called, right? The start method is called on the frame when the script is enabled. For most of our components, this will be when you press the start button in Unity. The awake method is called just before the start method. That gives a very convenient place to set up code if you have any. The update method is very specific. It gets called every frame that the game is running, which can be anywhere. It depends on your hardware, right? It can be 30 to 60 frames per second or even more if you have a really fast machine, right? All right, so we're going to do this just to show you how that works, right? So we've got learning methods. We're going to create a script called learning methods, right? Here we are, project, script. Learning methods. All right, switch over here. All right, so here's what we need. So note that the awake function is not given to you automatically, right? But if you start typing it, it will recognize that's what you're trying to do. Right? We're going to put debug.log awake function is called start debug.log start function is called update debug.log update function is called. All right, save that. so turn to learning methods. We'll put that on the camera too. All right. Click on the camera, make sure it's there. It is. Let's run it. Console open. And run it. You will quickly get tons of, go ahead and pause that. All right. Just scroll all over the top, you'll see await functions call, start, and update, and you just get tons and tons of updates, right? Because it's called every like 60 times a second, right? So that shows you how that works. Components that communicate using dot syntax. All right. Dot syntax is just a way of addressing objects and their components and getting to the very component or the part of the object that you need to use, right? It's just a reverse addressing system, right? If you look at here is his address, right? United Kingdom, Bedfordshire, Sandy, 10 My Street. Looks funny, right? Because it's backwards, right? Because usually we start with the most general. We say your name, and then your street, and then the state, and then the country, right? Computers do it backward. They start with the more general, and they go to the specific, right? And we'll look more about that too. This first chapter, or the second chapter, he kind of throws a bunch of generalities at you. Don't get too overwhelmed with them. I think in some ways he makes a mistake doing that, but it's just the way he writes. And it's a good book. Other than that, I think once he gets into the actual details, it makes more sense. All right. Making decisions in code. All right, so obviously in code, there's many times where we're not going to always run the same code, right? If we're have an RPG and we throw a fireball, right? Something different needs to happen if that fireball hits the enemy or if it doesn't hit the enemy. If it hits a wall, it does something different than if it hits the enemy, right? So there has to be a decision made on what happens then, right? So obviously, there has to be a way of making decisions in code, and that's what this is about. All right. All right, so we're going to create a script called learning statements now. There. Stop that. All right. And let's come here. Create C# script learning statements. All right, switch here, open that up. All right, switch there. All right. Public bool, will it be raining today? Equals true. Start if will it be raining today? Debug.log. Yes, you need an umbrella. I'm correcting his grammar. All right. Else debug.log. No, you don't need an umbrella. Save. All right. All right, so let's look at this. All right, so what we're going to do, first off, go to the main camera And we don't want to use these other learning scripts right now, so we're just going to turn them off by just unchecking them, right? Because that one, it gives us 5,000 update functions, and we don't need that right now. Right, so we're just going to turn off those scripts and just use the learning methods one, right? So we'll run it. And go to the console. And wait. Okay, I thought I turned that off. Okay, I'm not sure why that did that. All right, so that's the learning methods. I didn't connect the learning statements yet. All right, so I need to turn that off as well. Oop, like that. And learning statements needs to be connected to the main camera. All right, there we go. Now let's go to the console, play it. All right. Yes, you need an umbrella. Why is the wake function is called still there? Huh, that's weird. I don't know why that wake function is called showed up at all. Clear it. Clear on play is activated, so I don't know why that's happening. There must be something else. Huh. I don't know. I'm just going to put something here so I can see if that is where it's being called. All right. How is that happening? All right, I'm going to investigate this and see if I can figure it out. Okay, I'm not really seeing what is causing that to be called. Because if you have it off, in my mind, it's not supposed to be calling anything. So I'm going to remove it. I just want to see if it still does it. I'll clear it just to see. Okay, it did go away then. I'm not sure. I'll have to figure out why that actually occurred, because that is contrary to my knowledge of how Unity works. But they're always changing things, so who knows? All right. Using the not operator to change the condition, right? The not operator looks for the opposite of whatever. It basically negates the truth value of whatever is there, right? So if we want to say, if we want to look for if it's not raining, right, this is going to make the statements incorrect when you do it, but if this will give you the opposite answer, right? So if we run that, it should say, no, you don't need an umbrella, right? Because it thinks that, because it's true here, right, that the opposite of true is false. So if false, right, and nothing's ever false, right? You're always looking for true, right? So it gives you, no, you don't need an umbrella. All right. You can check for more than one condition in any statement, right? You can have if, and you can have use an and, or you can use or, right? You can use else if to make complex decisions, right? Right, and this is the one that I want you to turn in right here, right? Using else if to make complex decisions. So this is the bit of code I want you to turn in, right? And here we will use the output text to make sure that actually shows up on your screen, right? So let's do that. You know, he doesn't even tell you to create a new script. Sometimes I disagree with what he's doing, right? So we're going to create a new script, all right? So come into Unity, project, and we're going to say create C# script, making decisions, right? And then we'll open that up. All right. So let's go up here, int speed limit equals 60. All right, in start function, we're going to say if speed limit equals 70, debug, debug.log. I'm gonna get the kind of the framework for this all down first, right? Else if debug log, else if speed limit less than 70 and speed limit is greater than or equal to 30, else if speed limit is less than 30, debug.log. All right, then I can just put in my sentences here. Speed limit less than 70, more equal. I'm doing shorthand here because I don't want to type all that. All right. I better be driving slowly. Right. And if you want to type it all out, that's up to you. I'm not feeling very typalicious today. I can drive at maximum speed. Right. All right, so that's our making decisions code. All right. Let's run it first, make sure it works. We're going to put making, all right, so let's do that. Making decisions on main camera. Click on main camera. Let's just make making decisions our only script on there, right? And then make consoles open. We'll run that. All right, speed limit less than 70, more or equal to 30. That's right. All right, so now we need to make this so that we can print it to a screen so that you can actually use this for class. And we're going to say using Unity Engine UI public text output text. And so, like I said in class, every time that you have a debug log, you're going to echo that same text out into your output text, right? So before I even type the output text thing, I'm going to come in here and copy everything between the parentheses, but not the parentheses. I just copy that, Command C, and I can say output text dot text equals, and just paste that there, right? And I'm going to do that again here, right? Copy that. Then output text dot text equals paste. Oh, whoa, ding dong. All right. Well, I forgot that I didn't copy the quotes, so I need to do that. All right. And then better be driving slowly. Copy and output text dot text equals paste. All right, see what I did there? Cool. Now I can come in here and make sure that everything's hooked up. In fact, it's not, right? So there's an output text is a separate script over here, so we got to cook that up in this script too. All right, now we play that, we should get output. All right, there we go. And this is what you would create a WebGL of, and you would put in your scripts and upload that to Moodle, right? And that's really, you don't have to do this part here. This is kind of an extra little thing, so don't worry about that. And I will be creating another video soon for next week. All right, see you soon.